This week we're going to talk about those warnings that you've been seeing from Datetime about UTC and time zones. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. We're thrilled to be able to bring back MetPy Mondays on an every other week schedule, and for this first MetPy Monday, I wanted to talk about something that I've been running into more and more since our last MetPy Monday, which is some deprecations that are coming up in Datetime and how they may affect you. In meteorology and earth science in general, we use time a lot. It's actually the index for most of our data because we care about how things occur throughout the day or even throughout longer time scales. So let's go ahead and recreate what you might have been seeing from Datetime. I'm going to import Datetime, and then I'm going to call something like datetime.utc now. And we see this deprecation warning come up. It says that UTC now is deprecated and scheduled for removal in a future version. This might be slightly alarming because we use UTC as a time zone, if you will, in many of our meteorological data sets. So what do we need to do? Well, it turns out that we're moving towards time zone aware objects in Python. In traditional date times, such as this one, this is a time zone naive datetime object. It doesn't know anything about what time zone it's in. It just knows that we are on the 29th day of the 10th month of 2024, first hour, 30 minute, 27 seconds, and some fractional seconds. Okay, well, in this case, I told it UTC now, so that's UTC. But what if I've got some other date time that I've created that's not in UTC? Well, we can get into trouble doing date time math. In a lot of situations, that doesn't matter. All of your data sets for meteorology are probably in UTC, or your server time is always in UTC. But this is something that Python's moving towards to try to get a more consistent interface for time zones and date times. Whether that's a good or a bad call is certainly up for debate. There are the arguments that doing this imposes extra overhead on datetime objects, extra storage and RAM, and extra compute power for situations where we don't need time zone info. But this is the way things are moving, so let's see how we can fix it. But first, I did find a fun example from an issue that was filed a while back that really shows where you can get into trouble with this problem. So I'm going to use the UTC from timestamp function and 0. So this is 0 seconds since the origin of UTC timestamps. And we see that we get, as expected, midnight, January 1st, 1970, the beginning of time as far as many computers are concerned. We still get our deprecation warning here. But let's say now I'm going to make a datetime object, the same time, 1970, January 1st, 0Z. I'm going to call that DT. Yep, there it is. Datetime.timestamp of my DT. We see we get an OS error, invalid argument, which doesn't make a lot of sense. So let's expand this. I'm going to just copy in my date time here. Okay, I get the same error. Let's start messing with the hour. For 15, no. Let's try 20. Oh, 20 we get something. 17, no. 18. Okay, so for 18 hours on January 1st, 1970, I get a timestamp of 86,400 seconds, which that's the number of seconds in a day. Well, it turns out this is because I've got an offset from UTC time on my computer. And since the datetime object doesn't know what time zone it's in, we're operating in local time. So 0Z on January 1st, 1970 is not a valid time. It's pre-origin Unix time, because right now I'm several hours earlier than the UTC 0 time zone. Okay, so let's see some ways that we can get around this. I can take the exact same thing, but I'm going to change it back to 0Z, where I get my error. And I'm going to set time zone info to be timezone.utc. I'm going to insert a cell above, so I can, from datetime, import time zone. And now it works because we know that that January 1st, 1970 0Z is indeed Z. It's UTC time. So we get the correct timestamp back. So how can you create date times with a time zone aware? Well, we see one way here. I'm adding the time zone info argument to my creation of the date time. But what if I'm not in UTC? Let's say I'm in, right now I'm 5 hours earlier than UTC. So from datetime, I'm going to import time delta. And I'm going to make a variable called 1600 local. Datetime will stay with today's date, 16 for the hours. TZ info equals time zone. Instead of .utc now, I'm going to specify time delta. Seconds equals -5 times 3600. Or we could say hours equal -5. Either will work. Now we can see that I've got a time zone, the same day, 1600. My time zone info rolls back a day and then forward 68,400 seconds, which gives us 5 hours earlier than UTC. So now if I take my 1600 local and call .as timezone, timezone.utc, we see that we get 21Z, so 5 hours ahead of the date time that I created. While it will probably be several years before UTC now and the associated functions such as UTC from timestamp are removed from Python, it's a good idea to go ahead and update. The update doesn't take too long to do to your code. You just need to go ahead and tell it whether you're in UTC or a different time zone. Now, specifying different time zones is a little bit clunky unless you use some additional utilities, and we'll talk about those on the next MetPy Monday.